Welcome to Preparing for the ACT 2021-2022, the science passage, number 4. If you want to look at a specific question and how I explained how, just click through the chapters to find that one. So in this passage, we're talking about ammonia, and it can be produced according to this chemical equation. So we've got these two ingredients, N2 and 3H2, and they make 2NH3, which they say is ammonia. And this whole paragraph right here is all about the word equilibrium, meaning that you can make this stuff, but then it can also break down. And equilibrium happens when both of these are sort of happening simultaneously at the same rate. It's being made and unmade at the same speed, I guess. Now, they say that equilibrium can be shifted forward or backward by changing the temperature, the pressure, or the concentration of reactants or products. And so what they give us is they give us this picture. And so here are our two ingredients down here. We've got H2 and N2. We've got this reactor. Something happens in there. I'm not quite sure. We have these two pipes, pipe A and pipe B. We've got a condenser. And then we've got this arrow with NH3, which is ammonia, going out. Now, these 4 steps tell us what happens. A catalyst, W, X, Y, or Z, are placed into the reactor. So we've got H2 and N2, but then we've also got either W or X or Y or Z being added in to this. And number 2 says they react at a constant pressure until equilibrium has established. And then what they say is in step 3, a mixture of NH3 and any unreacted H2 and N2 flowed through the pipe to a negative 50 degree condenser. So along this path, we've got H2, N2, and NH3. They're all going this way. Then it says in number 4, NH3 condensed and exited the apparatus. H2 and N2 do not condense. Any unreacted H2 and N2 flowed into pipe, returning to the reactor. So, off of this, going back, we've got H2 and N2 going back. So if there's any excess H2 and N2, they go back into the reactor, but NH3, the ammonia, that goes out. That's what happens. That's what this is telling us. And then we repeat this cycle until both the ingredients, H2 and N2, are all used up. So experiment 1, we have 9 trials. And so what are we comparing? We're comparing temperature with the number of cycles. That is the number of cycles until they ran out of ingredients. And what's different with each of these is which catalyst was used. So different extra ingredients affect how many cycles they have to run. Experiment 2, then it says 4 sets of 9 trials conducted with catalyst Z. That's probably an important detail. Here, the temperature was different. So here we've got different temperatures and then also different pressures. And this is giving us the amount of ammonia that it produces. So let's see what the questions are asking us about. Question 21. According to the results of experiment 1, for any given catalyst, that means it doesn't matter whether we added W, X, Y, or Z. The question is, as temperature increased, so as temperature got bigger, what happened to the number of cycles? So let's take a look. So for catalyst W, as temperature goes up, number of cycles goes up. And we see the same thing for X, for Y, and for Z. They're all going up. So that's why the answer for 21 was they increased only. All those graphs going up, they never went back down. Number 22, in experiment 1, 26 cycles, that seems important, were needed to complete the reaction at 450 degrees when which catalyst was used? So it's telling me, look at experiment 1, 26 cycles, 450 degrees. Okay, I can do that. So I'll erase all this. So I want 26 cycles and, let me see, what was the temperature again? 450 degrees. So I want 450 degrees, so that's right in here. And I'll use a different color. And I want 26 cycles, so that means it has to be this one right here. So the question is, which catalyst was used? So that's a triangle, so that means we're talking about catalyst X. So that's why the answer was letter G. 23. The movement of H2N2 through the apparatus is best described by which of the following? Well, this is a summary of the picture. That's what we're summarizing here in 23. So the question is, where do the ingredients start? They start in the reactor, and then they go through pipe A to the condenser, and then they go back through pipe B back to the reactor. So the only ones that start with the reactor are letters A and C, but then to get from the reactor to the condenser, you have to use pipe A. So that's why the answer is letter C. 24. Consider the results of experiment 1 for 375 degrees. All the N2 and H2 were consumed in less than 20 cycles when which catalysts were used? So what we have is 375 degrees and less than 20 cycles. So let's look at experiment 1. So 375 degrees is right here. This is what we're looking at. Now our threshold is less than 20. So if I draw this line, I'm only concerned about the ones that did less than that. So that's these three down here, the triangle, the square, and the star. So that is catalyst X, Y, and Z. Catalyst W took more than 20 cycles. So that's why catalyst W we don't include. So that's why the answer is letter J. 25. If a trial had been performed in experiment 2 at 425 degrees and 225 atmospheres, the amount would have likely have been, all right, so now we're looking at the other experiment, 425 degrees, 225 atmospheres. So let's take a look. So we said 425 degrees and 225 atmospheres. So 225 is right in here, 225. But 425, well, that's not a temperature, but it's in between these two. So wherever these two are, 425 is going to be somewhere in this range right here. So let's see, the star is just over 200, so we might say that's about 220. And the square is about halfway between 3 and 400, so that's about 350. So somewhere in here is where 425 should fall. We're exactly not sure. Now let's look at our answers. We want as close to 220 to 350 as we can. And this one is the closest to our estimations, 230 and 320. Number 26. At 1 atmosphere of pressure, the melting point is negative 77 and the boiling point is negative 33. So let's remind ourselves that this is ammonia, not water. So negative 77 degrees, negative 33 degrees. So down below here, this is solid. Above 33, this is a gas. And between them, it is a liquid. So the question is asking, based on this information, when the NH3, the ammonia, exited the condenser, was it a solid or was it a liquid? Well, the only way to determine whether it was a solid or a liquid is, was it above or below negative 77 degrees Celsius? Now let's look back at what they said about the condenser and the temperature. And that's right here in step 3 and step 4, because it says a negative 50 degree condenser. That right there tells us that's the temperature of this part of the NH3. So it's exiting at negative 50 degrees Celsius, which means negative 50 degrees on this scale is going to be right in there. So that means the ammonia is going to be exiting as a liquid. So F and G are out. And so the explanation is because the temperature of the condenser was between the melting point of NH3 and the boiling point. Okay. It was not higher than both of them. It was in between them, as I've drawn for you right here. 27. Consider the trial in experiment 2 that produced 550 kilograms of NH3. Now that's all they tell us. Now this is the last one in this section, which means it's probably pretty tough. And that's because they want you to go find that. So I'm going to go find that right now. Experiment 2, 550 kilograms of ammonia. So 550 is right about there. So the closest one that I can see is this one, because no others seem to fit right there. So what is that? So that's 300 degrees Celsius and 150 atmospheres. Now, the other thing to point out is that we're using catalyst Z. Now let's go back to the question. It says, based on figure 1, so now we have to take this information, go look back at figure 1. It says the number of cycles that were needed to complete this reaction was most likely what? So we needed this experiment to tell us what we were talking about. We're talking about catalyst Z at 300 degrees Celsius and 150 atmospheres. So now we take that up here, and now we say, all right, well, I'm only interested in catalyst Z right now. So that's the stars. And then we've already said that, hey, we're only looking at 300 degrees. So that means we're looking at this right there. So how many cycles is that? Well, it is definitely about 2 or 3. That's the number of cycles that it took. So if I look back at my options, the only one that works is less than 5. Thanks for watching, and don't forget to watch all the other videos on this